Okay, Module 6, Surface Patterns of Pressure and Wind. Well, if you've ever watched a weather forecast on television, quite often it begins with a report of current conditions from the nearest airport. These conditions usually include temperature and relative humidity, wind speed, wind direction, as well as the atmospheric or barometric pressure. Of course, the first few are very understandable. Most people know when it's hot or cold outside. They know that at a high relative humidity, that means it's going to be kind of muggy outside. High wind reading is, of course, that means you'll be holding onto your hat. However, many people would be hard-pressed to give a good explanation about atmospheric pressure. Now, it must be important or it wouldn't be reported on the news. But what is pressure and why do we care about it? That's one of the main topics for Module 6. To me, the best way to thinking about air pressure is to just kind of wave your hand back and forth in front of you, really fast. Are you doing it? What do you feel? Your nerve endings are telling you that you're hitting something. You can feel something, right? Your nerve endings are saying, hey, I'm hitting something. And it turns out what you're hitting are air molecules. We can't see them, but we can certainly feel them. We often don't think that air has weight, but it really does. What you're feeling when you wave your hand in front of yourself, you are feeling the mass of each air molecule. Now, each individual air molecule does not have much mass, but think about the cumulative effect of a column of air molecules stacked from the surface of the Earth to the edge of the atmosphere. That can result in quite a bit of weight. Turns out the weight of the air column above you is what we refer to as air pressure. At sea level, the weight of the air column results in an average pressure of about 14.7 pounds per square inch. Of course, at higher elevations, there's less air above you, so that means the pressure will be lower there. In this module, we're going to learn about how air circulates around high and low pressure systems. Now, did you know that the wind doesn't just blow from high pressure to low pressure? It turns out there are several different forces that work together, including the pressure gradient force, that means a difference in pressure, the Coriolis force, and even friction. Another topic we're going to revisit in this chapter is fronts. We have already covered the temperature patterns associated with different kinds of surface fronts, and in this lesson you'll learn about pressure and wind changes across a front as well. At the end of this chapter you'll have enough knowledge to be able to interpret basic surface weather maps. Skills such as identifying centers of high and low pressure, fronts, spotting troughs and ridges, figuring out wind direction and relative speed, these are all within your grasp after you finish this module. Combine these skills with your understanding of satellite and radar imagery from last module, radiation, temperature, atmospheric moisture, and you've got a pretty complete set of useful weather analysis tools.